download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about the microscope. Now, cells are studied using microscopes and therefore they have become incredibly important in allowing us to see what really is inside of cells. Now, before we get on to learning about cells and the microscope, we need to learn these two definitions. The first of which is magnification and the second of which is resolution. Now, magnification is how much larger an image appears compared to its actual size. So the larger we make an image appear, the higher, the bigger the increase in magnification that we've given it. And then the resolution is the ability to distinguish between two separate points. Really, by that we mean how sharp an image appears. Now, there are two types of microscopes that we need to be able to compare, and that is a light microscope and an electron microscope. Now, a light microscope obviously uses light to magnify an image, and an electron microscope obviously uses electrons to magnify an image. Now, electron microscopes have much higher magnification, so they can make images appear much larger than they actually are, whereas the light microscope has lower magnification. An electron microscope also has higher resolution, so the images produced from electron microscopes are much sharper, whereas light microscopes have a lower resolution. Light microscopes, however, are cheaper, whereas electron microscopes are expensive, and light microscopes are also, you can easily transport them. Now, these are the microscopes, the light microscopes that you will see in school, whereas electron microscopes are much larger, therefore they are harder to transport. Now, in biology, we're looking at incredibly small things, and therefore we need to be able to use the appropriate units and be able to convert between them. The more common units that you'll come across in biology are the millimetre, the micrometre, and the nanometre. Okay, and you need to be able to convert between these. So to get from millimetres to micrometres, you have to times it by 1,000. And to get from micrometres to nanometres, you also have to times by 1,000. To convert back from nanometres to micrometres, we divide it by 1,000. And to convert back from micrometres to millimetres, we divide it by 1,000. You may occasionally have to know about centimetres, and to get from centimetres to millimetres, you just times by 10. And to get from millimetres to centimetres, you just divide by 10. So let's go through a worked example. Convert 8,212 micrometers to nanometers. So that's the first worked example. So to get from micrometers to nanometers, we have to times it by 1,000. So we do 8,212 times by 1,000, and that should equal 8,212,000 nanometers. Let's go through one more example. So this time we're going to convert 4,782 nanometers to micrometers. So this time we're going to do nanometers to micrometers, so that we divide by 1,000. So 4,782 divided by 1,000 equals 4.782 micrometers. So I want you guys to have a go at converting these units. So we've done the first one for you. So we've converted 5 nanometers to 0.0005 micrometers and 0.000005 millimeters. I want you to have a go at converting the rest. So convert 1 nanometer to micrometers and millimeters, 1 micrometer to nanometers and millimeters, and so on. Okay, so let's run through the answers then. So to get from 1 nanometer to micrometer, we had to divide it by 1,000. So you should have got 0.001. And then to get from 0.001 micrometer to millimeters, you divide by 1,000. So you should have got 0.000001. To convert 1 micrometer to nanometers, we times it by 1,000, so that would be 1,000. And then from micrometers to millimeters, we divide it by 1,000, so that would be 0.001. To get from 1 millimeter to micrometer, we times by 1,000, so that would be 1,000. And then from micrometer to nanometer, we times by 1,000 again, so that should be 1 million. To get from 3 micrometers to nanometers, we times by 1,000, so that will be 3,000. And we divide by 1,000 to get micrometers to millimeters, so that would be 0.003. To get from 7 nanometers to micrometers, we've got to divide by 1,000, so 0.007, and divide by 1,000 again to get into millimeters, so 0.000007. And finally, millimeters to micrometers, so 0.5 times 1,000 gives us 500. And then 500 times 1,000 to get micrometers to nanometers equals 500,000. So I hope you got all those correct. If you did not, you may need to go back and just relook at converting units. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. So you may be asked to work out magnification or image size or real size when you're given some different values. So we need to remember this equation. Magnification equals image size divided by real size. Now the image size is obviously the size produced from the microscope, and the real size is actually the real size of whatever it is you're looking at. So let's go through this worked example. So question 1, an object of 4.5 millimeters wide is viewed under a ×600 magnification. How wide is the image? What I always like to do when I'm giving a question and having to work out a value is I like to write down what I know. So an object of 4.5 millimeters wide, so that's the real size. So the real size equals 4.5 millimeters. Under a magnification of ×600, so that's the magnification there. So we know magnification equals 600. Then what I'd like to do, and what I do, is I put those values into our equation. So magnification equals 600 equals image size, which is what we are trying to work out. So I'm going to call that I, divided by the real size, which is 4.5 millimeters. Okay, then what I need to do is I need to rearrange that equation to get I on its own. So to get rid of the I, or get I on its own here, we need to get rid of this divide by 4.5. We can do that by timesing both sides by 4.5. So we get the 600 times 4.5 equals I divided by 4.5 times 4.5. So they cancel each other out. So 600 times 4.5 equals I. So if we do 600 times 4.5 on our calculator, we get 2,700. Now, here the object is given us into millimeters, so this will also, the answer will be in millimeters. So we should have got 2,700 millimeters. So what I'd now like you to have a go at is answering these two questions here, and then after that we'll go through the answers together. So pause the video now. Okay, so let's go through. So an object that is 200 micrometers long is viewed under a microscope of ×2,000. How long is the image? So again, write down the values we know. So the real size is equal to 200, and then magnification is equal to 2,000. Now also might be a good idea if we rewrite the equation above so you don't forget it. Magnification equals image size over actual size. Okay, so we're trying to work out the image size, so let's input our values. We've got 2,000 for magnification equals image size, which we're trying to work out, divided by actual size, which is 200. Then we times both sides by 200 to get image size on its own. Them two cancel each other out, so it's 2000 times 200 equals the image size, and then we want to put that into our equation, into our calculator, to get 400,000. Okay, so that will be, again, because it's given us in micrometers, the answer will be in micrometers. So question 2, a sample of food infected with bacteria is viewed under the microscope. The bacteria are 0.5 micrometers long. How will they look when using, or how big will they look when they're using a magnification of times 1500? So the real size is 0.5 and the magnification is 1500. Input this into our equation, so 1500 equals I times 0.5, then 1500 times 0.5 equals I, so our image size is equal to 750, so you should have got 750 for that one, and again they've given us it in micrometers here, so that will be micrometers. Because we're dealing with really small numbers, we need to be able to use standard form. So I'm going to teach you how to use standard form now. So the first question here is write 5.6 million in standard form. Okay, so step 1 when we're doing our standard form questions is we need to find a number between 1 and 10 that 5.6 million can go into. Okay, so the number between 1 and 10 this will go into is 5.6. Okay, because here we got 5.6 million, so 5.6 is going to be the number. Okay, then step 2, we need to write our standard form like this. So it will be 5.6 times 10 to the power of something. Okay, so we need to work out what it is to the power of. And the way we do that is we count how many decimal places the decimal has moved to go from the original number to our number between 1 and 10. Okay, so if we have 5.6 million here, okay, that's 5.6 million. The decimal point is obviously going to be here, okay, that after the number. Okay, so we need to find out how many times that decimal point is moved to get 5.6. So let's count 1, 2, 3, 4, 5, and 6. Okay, so that decimal place has moved 6 times. So that means this number here is going to be 6. So we can write 5.6 million in standard form by saying 5.6 times 10 to the power of 6. And that is your answer. Let's do another one just to make sure you understood. So step 1, what number between 1 and 10 is this going to make? So 32,000 is going to make 3.2. And then step 2, how many times has the decimal place moved to go from 32,000 to 3.2? So 1, 2, 3, 4 times. So 4 times. So we write 3.2, which is a number from here, times 10 to the power of 4, which is the number from here. So because in biology we're dealing with really small numbers, it is more likely that we were asked to put numbers in standard form when they are really small, like these numbers here. But the steps stay the same, so I'm going to talk you through them now. So step 1, what number between 1 and 10 can we make this number? So we've got 0.00045. The number between 1 and 10 is going to be 4.5. Step 2 is then going to be count the amount of places the decimal has moved to make it 4.5. So the decimal is here. We've got 1, 2, 3, 4. It's moved 4 times, so that's what we write here. Okay, so we're going to write 4.5, because that's our number here, times 10 to the power of 4. However, because we now move to the right, because we're dealing with the smaller numbers, it will put minus 4. So it's not going to be normal 4, so it's minus 4. So the answer, 4.5 times 10 to the power of minus 4. There we go. So let's do one more. Step 1, what number between 1 and 10 can we make this? 1.5. Step 2, how many places has the decimal place actually moved to make it 1.5? So let's count. 1, 2, 3, 4, 5, 6 and 7 places. Therefore we write 1.5 times 10 to the power of, because it's moved to the right, minus 7. And that is your answer. So what I'd now like you to have a do is have a go at these to make sure you really understand it. So pause the video now. Okay, so let's go through the answers. So in step 1 you should have got the number 3.8. And then in step 2 you should have counted the decimal place movement. So 1, 2, 3, 4, 5, 6, 7. So your answer should have been 3.8 times 10 to the power of 7. Here, the number we should have chosen is 3.2. And then in step 2, we need to count how many places the decimals moved. So 1, 2, 3, 4, 5, 6, 7 places. But because it's backwards, it's going to be negative 7. So our answer will be 3.2 times 10 to the power of minus 7. So I hope you got those right. In this rather large video, we've learnt about the microscope, and we've learnt to compare between an electron and a light microscope. We've looked at converting units, we've looked at the magnification question, and we've looked at standard form. You can now move on to the quiz and test yourself using the exam questions. However, if there's anything you don't understand in this video, then please get into contact with one of our tutors who will happily help you out.